All right, so this is 8-7 base E and natural logs. So we've been talking about logs this entire time. And now this is just like we had common logs, which is base 10, and now we have base E logs and natural logs. So if you flip to 8-7, your homework right there is 20, 29, 34, 35, 38, 41, and 43. But if we flip to 8-7, we get here. All right. So E is kind of like basically what pi is, what the square root of 2 is. It's just E equals this number. So kind of like how we know that pi equals 3.14 and it goes on. E equals 2.718 and it goes on. All right, E is just a number. It's on your calculator. I'll show you how to use it. But that's E. Now there's a couple things we need to note. One thing here is that if you have ln x, this can convert to log e of x. So we're going to use this a lot, especially when we're writing in different ways. We're going to be writing stuff. And then we have this kind of cool system. And you can almost think of this as like ln. Basically, ln and e, they hate each other, basically. All right? So what happens is they kind of cancel out. Where if you have e to the ln x, this can just break down, these cancel each other out, and you're left with x. That's why this right here equals x. And the same thing here, when you have ln times e to the x, these two parts cancel out, and you're just left with x. That's why it equals x. So we're going to be using this a lot when solving. It's actually, I think it's really fun and really cool. But first part now, one thing you're going to have to make sure, a little typo, but this is an x there. And all we're doing here is we're going from exponential form to logarithmic form. And we want to go to ln. All right. So our first step, we have e to the x equals 8. And our classic formula we're always using is still around. Now my b is e, x is where y is, and then 8 is y. So when we convert this, you have e, 8 is y, or sorry, 8 is x, equals x. Because that's where y is, and 8 goes there. Oops, sorry, that's where x is. There we go. That makes more sense now. So you have x that goes there, the y goes here. It's the same formula we've always done. And now, when we talk about this note, I said if you have log base ex, that equals the same thing as ln 8 equals x. So when you have log base e, you can go into this natural logarithm. All right, so ln means natural logarithm. So if we're going to do this example here, kind of just mimic what we have done. So here's my b, here's y, here's x. So I have log e 9 equals x. All right? And then the last step is that this log e turns into ln, and you have ln 9 equals x. So it just says write in a different form. That's all you're doing. You're just writing it in the different form. And then you can actually go back and do the other way. So that's the second part, is just going back. So if you have ln x is approximately 0.7741, we can, instead of having ln, we go back to log base e. X is approximately, we'll just use equal 0.7741. And then you can go, and this is b, this is your x, this is your y. So we have e to the 0.7741 equals x. All right, so that's just from the same formula we've always done. It's just going from ln x to log to exponential. All right, so this is natural log. They mean the same thing, they're just a different look again. Those two concepts are not as important. We're going to get to more of the important stuff. And that's part 3, is being able to simplify expressions with base e and natural logs. And notice we have the 3 times ln 10 minus ln 8. Again, we can use that power property and move the 3 up here. So we have ln 10 to the third minus ln 8. Subtraction, we've talked about this before. Now that's the quotient property. That means division. So we have ln 10 to the third over 8. So we can go from 2, just like we did with logs, you can go from 2 ln's just to 1 using that quotient property. And then now it's about just simplifying it a little bit. So 10 to the third is 1,000. So we have ln 1,000 over 8. I'll show my work up here now. And then that means that 1,000 over 8, you have ln 1,000 divided by 8 is 125. And what you can do here now is if you wanted to break it back down, you could go to like ln, this is 5 to the third, which you could bring this down, and you would have 3 ln times 5. So 3 times ln 5. This basically is 90% of the work. This would be just that extra simplifying that I'd be looking for. All right. Now B with addition. Again, these are all exponents that go above. So you really have ln 5 squared plus ln 2 to the fourth plus ln 5y. So 5 squared is ln 25 plus 2 to the fourth is ln 16 plus ln 5y. Now you're going to want to add these, but what do we do before with logs? We multiply them. So you have ln 2000 y, because 25 times 16 times 5 is 2,000, and that would be your simplifying. This is using a lot of the property stuff from 8.5. More importantly, the most important parts of this section are being able to solve in base E. Using either equal sign or inequalities, they're the same things, we don't have to worry too much about it. But our first step is I want to get the E by itself. That's my first step. I want to do all my stuff there. So I'm going to add 5 over. So I get 4 times e to the negative 2x equals 8. E is not by itself yet. It has this pesky 4 multiplied with it, so we're going to divide by 4 on both sides. So we have e to the negative 2x equals 2. All right. So if you want to write out first step, get e to the x by itself. Once we're here, the cool thing about natural logs, like I talked about here, is this kryptonite effect. So if we have e to the negative 2x, I can ln both sides. So I'm going to ln e to the negative 2x equals ln 2. Again, if you have an ln and an e, they cancel out. You'll have a negative 2x equals ln 2. You can divide by negative 2. And you get x equals ln 2 divided by negative 2. You then use your calculator to find this, and you get x equals negative 0.3466. I think this part is awesome. That's so cool how it does that. All right, let's go to part B now. So you have 3 times ln 4x equals 24. Now 3 is multiplied with this entire thing, so we can divide by 3 first. I want to get ln 4x, same kind of thing. I want to get it by itself, equals 8. Now that ln's by itself, what gets rid of ln? E does. So I can do e to the ln 4x equals e to the 8. When you bring in e, the numbers that are already there go into as exponents. These cancel out, so now you're left with 4x equals e to the 8. You can divide by 4. And you have x equals e to the 8 over 4, which this equals, x is going to equal. When you plug this in to your calculator, notice right down here, it is right where ln is. So you have an ln button, as well as you have a second, and if you hit the L button, it gives you e to the, and then we would hit 8, divide by 4, and you get 745.2394. 95, we round up. There we go. Again, kind of cool. I think it's pretty sweet. And then C, we have ln times x minus 4 to the fourth is less than 4. Now, ln is by itself, right? There's nothing in front of it. There's no like plus 4 anywhere or minus 5 like we had before. We're going to, right off the bat, use e. So we have e to the ln x minus 8 to the fourth is less than e to the fourth. These cancel each other out, so you're left with x minus 8 to the fourth is less than e to the fourth. Now I have to get rid of this to the fourth. What can I do? I need this to become a 1. I can bring this to the fourth, like 1 over 4. These cancel out each other. You're left with x minus 8 is less than e. Add 8 over, and you have x is less than e plus 8, which means x is less than 10.7183. Kind of cool how it does that. I think that's pretty neat. Now if you flip the page, one last little part, and this is with continuously compound interest. This is a cool problem, I think. Kind of made it up a little bit. But again, we have this formula, A equals P times e to the RT. Tells you what A is, T is, P is the principal, and R is the annual interest rate. All right. So the example here is when you get your first job, you should probably deposit your first $12,000 into a retirement savings account, which pays 7% interest compounded continuously. Now, the reason why I chose 7% is because that is actually what they tell us for an interest rate if you are going to open up a retirement account. 7% is basically what you need as an interest rate. So this is pretty actually factual of what you might need to do one day if you want to have money when you retire. So first off, here is the formula. We don't know A yet. We know the principal is $12,000. We just put E, and then our rate, it's a 7%. But we can't use that. We have to divide that by 100. So we get R equals 0.07. So you have 0.07, and it says after 10 years. All right, so our next step, I have 12,000 here. E to the 10 times 0.07 is just 0.7. And then you're going to do the exponent here. So you have E times E to the 0.7. And you're going to get A equals E to the 0.7 is roughly 2.014. And you're going to multiply that with 12,000. So A equals roughly $24,165.03. All right. So after 10 years of after you invested $12,000 into your retirement fund at a 7% interest rate, after 10 years you have $24,000 in there. Now, second B, part B, I really like. This question actually fires me up pretty good. We have A equals P e to the RT. Now they say, how many years am I going to have to work in order to be able to retire? $300,000 is basically what they tell us. You need to have at least $300,000 in your retirement to feel comfortable living in retirement. That's what they told me at the meeting, I guess. So they're asking me, when I reach 300,000, how many years will that be? So A is 300,000. And I'm going to have to work at least how many years? So we'll worry about that. We'll just put an equal sign for that right now. Really, it's an inequality, but for right now, we'll just worry about the equal sign. P, that's the 12,000. That's our principal amount. And then we have E to the 0.07. That's our rate times T. All right, now this turns into an exact problem that we had before. I want to get E by itself, so I divide by 12,000. And there, 300,000 divided by 12,000 is 25. So you're left with 25 equals e to the 0.07 t. You have an e here. What can I do to get rid of the e? I can ln both sides. That crosses that out. So I have ln 25 equals 0.07 t divided by 0.07. And you will get that t equals roughly 45.9. If you round it up, it's approximately 46 years. T equals. So what does that mean? That's kind of cool to me, because it tells me, all right, if I invest $12,000 right off the bat, and I would have to, by the time I would get $300,000 in that account, I have to work 46 years. And then I am ready to retire, if that's where I want to be financially. I think that's sick. I don't know. Now, you can pay people to do that for you, or you could learn how to do it yourself and save yourself a lot of money doing this yourself. So, hey, it's up to you. I just, have a good day.